Now we're switching into something a little more familiar, which is the landscape of mobility, particularly in our cities, and how the world is going to change and how we get around is going to change. And we have three experts on that here, experts from some quite different dimensions. So if we talk about the future of transportation, one thing you often hear about are flying cars, and we have somebody who's making them over here. Rene Griemens of Volocopter, which is a European company that is pretty much, I think he'll tell us, ahead in the game to build some kind of flying car. Do you call them? You don't call them flying cars, do you? What do you call them?
I certainly called them flying car when I joined the company. So one of the main motivations was that I loved Bruce Willis in Fifth Element, cruising around New York, and that's what we will make happen.
Yeah, somebody in the green room was saying that she became interested in technology from watching the Jetsons. So I said, hey, you got a guy who's building that now. So thank you, Rene, for coming and helping us understand that. Over here, Tiffany Chu is with Remix. Now, she is more of a systems architect. Would that be a fair description of what you do? And a designer, really.
Yes.
And her company, Remix, is kind of like the kind of accidental company you really want to have happen to you, where if I might be, I'm going to ask you to describe it in a minute, but I guess I will not try to do it myself. But what Remix is doing is basically helping cities around the world reconceive their public transit systems, but it's really only the first sort of gambit in a way of rethinking how cities are designed overall. And I'm going to ask you maybe as soon as I finish the intro to tell us how Remix came into existence.
Sure.
And finally, a longtime friend of mine, John Suh of Hyundai, who is running the Silicon Valley office of Cradle, which is a part of Hyundai that's all about corporate venturing, open innovation, and special projects. So it's kind of like Hyundai's way of intersecting with all the cool stuff that other people are doing, and John is a visionary about what's happening, particularly with four-wheeled terrestrial vehicles. Right. But let's stick with Tiffany here for a minute and tell us what Remix is and how it came about.
Sure. So you can think of Remix as kind of like a sim city for the real world. And we actually got started about 5 years ago. My co-founders and I, we were fellows at a nonprofit called Code for America, whose mission is to help cities and local governments move into the 21st century with regards to technology. And we had built a grassroots project to help residents and citizens of San Francisco suggest better transit routes to Muni, to the SFMTA.
Sort of crowdsourcing it.
Yes, exactly. Crowdsourcing. Lots of people have complaints and grievances about the SFMTA. And so what better way than to harness all of that energy and provide recommendations, kind of grassroots. So it completely went viral on the internet, on Twitter, and we were...
Within days.
Within just a couple of days, we got written up in about 20 blogs, and then 200 urban planners emailed us saying, hey, I saw your prototype that you built. I want to use it for my long-range transportation plan, and here are 50 features that I would like you to build so I can use it. Thank you very much. And that was kind of how Remix was born.
And you didn't even know it was a business.
No, I mean, I'm an urban planner and architect by training. I'm not really a business person, although now, once you start a company, you're inherently a business person. And I think what I've learned through that is that through technology innovating really fast. For example, we were building this tool that was only possible because of open data standards and a lot of cool open source mapping components that were just coming out at that time. And without that, we would have never been able to build what is now Remix, the platform it is today.
So when you think about what you're working on and where it's going, talk about the data issue, since that's sort of a theme of the day here, and we are at a memory company conference. What's the data piece of what's now possible, and how is it going to evolve over time, would you say?
Yeah, so to give you a sense of what Remix does, we are a platform for cities, transit agencies, local governments to basically take disparate pieces of data that are probably in lots of different silos and databases stuck in different departments and bringing it all into the same place so they have a complete transportation picture of what's going on in their city. And I think the innovation there is not that the data itself is innovative, but it's about translating and visualizing in a way that's at planners' fingertips. Because before, if you were to ask any sort of planning question, like how many people live within a quarter mile of the stops of the 14R, for example, you would have to go and then ask your GIS person, who would take, probably 2 weeks to query that question, then come back to you, and it just makes government decision-making so slow, and that was actually part of the problem in planning. Planning was slow because access to data was slow, and that's what we seek to completely transform at Remix.
But and as we go towards, and maybe other panelists might want to comment on this too, as we go towards a more and more sort of optimized and planned urban environment for transportation and plenty of other elements, and the quantity of data that's going to be required to optimize that presumably is going to grow very rapidly. Again, as we mentioned in the last panel, especially with the 5G, IoT, everything, sort of throwing off data, right?
Yes. Do you guys want to speak to that as well?
Yeah, I mean, if you think about just the fact that you go into a third dimension and that you want to have autonomous.
Well, you're going into the third dimension, yeah.
that we are going into the third dimension, and we will fly autonomously in the third dimension, meaning we need to measure the space around us, and we need to confer with other participants in the airspace about where we want to fly. Then that's already creating a significant new dimension of data.
Yeah.
The same is happening on the ground with autonomous transportation.
And if John will allow me, I want to pursue that a little longer. I think you should tell us a little bit about Volocopter, why you are ahead and why you're so confident that your company is going to be the first one to have an operational, used by the public flying car or whatever you call it.
Sure. So our goal is to build the whole urban air mobility system, from the passengers over the air transport, traffic control systems and the fleet management systems behind it. But this is all based on the key to entering the market, which is having the first vehicle that it will be allowed to fly into cities. And we are fairly confident that we're the most advanced in this, because there is only one institution worldwide which is currently able to certify a vehicle, which is the European Air Safety Association, EASA. FAA, unfortunately, has not received the federal law that they would require to certify a vehicle to fly into cities. And therefore, EASA is ahead, and we are currently the only company with a flying vehicle in certification, which makes us reasonably comfortable to estimate a 2 to 6 years market lead for flying into cities.
2 to 6 years, between what and what?
Before the next participant could.
Oh, you'll be ahead by that many years. Wow.
Before the next participant could participate in the airspace. The president of the FAA recently estimated publicly that it will be another 4 years before the US has a certification standard to certify such a vehicle. And then he thinks that by traditional means of certification, it would be 6 to 8 years of certification.
So that's 10 years right there. Okay.
That would be 10 years. I would guess that they accelerate in some way to avoid being the last on the planet to certify such a vehicle.
Possible in our current environment, you never know. But when you are looking at what's going to happen, though, how soon do you think customers will be flying around in one of your devices?
Yeah, so we staged on Tuesday, 2 days ago, for the first time in a city environment in Singapore, over the Marina Bay, a manned flight. This one was with a certified test pilot, and we're getting ready to build the certified vehicles now. So we're at the stage where we are buying the component for the commercial fleet, meaning we're about 2 years away from commercial launch, from carrying paying passengers.
That's pretty amazing. But it'll probably be in place, Singapore or Europe, where we'll see the first. And they will be piloted to begin with, and the autonomous will come next. Is that the...
So we have tested and proven that autonomous works. We've shown that in Dubai, and we've also done in our own airfields. We've done several test flights with autonomous technologies. And we think that the regulators will actually be the bottleneck here to let us fly autonomously. So to accommodate regulators getting comfortable with the sector, we will certify first with a pilot on board, who will fly the aircraft with a joystick type of pilot device, and then later on we will add the autonomous function and certify that on top.
Now, what you're building, though, in the end is not a flying car, it's really a system, right? That's what Volocopter's real goal is to be sort of a systems provider, right? So quickly talk about that, and also, how does that, once it exists, dovetail with all the other systems like the ones that these two people are helping build?
Yeah, it's very closely interlinked. So we are building the system for a multitude of reasons. The very obvious one is that there is none and somebody needs to start it. We have the first vehicle which attracts a lot of people to cooperate with us and collaborate in building the first system on the ground. So most of the leading edge air traffic control technology companies are cooperating with us. Ground infrastructure providers are cooperating with us to make this a reality in the first countries where we will introduce the service. And the vehicle, as I said, is the key to opening this market, but a little bit in the way that Apple eventually migrated from a hardware manufacturer to the provider of the ecosystem in a device like the iPhone. We will also hand over the hardware manufacturing to production partners and then move on to managing the ecosystem. And of course, the work that the two of you are doing is essential to continue building this system.
Okay.
We need people planning the architecture of the city in the third dimension.
Right.
And interlinking this with other means of mobility.
Great. So John, what you do is something that's easier to understand, perhaps, or envision, and we're all familiar with it, obviously. But where is it headed? I mean, you're a sort of automotive futurist, right? And you know, clearly we have two futurist-oriented people. She's very much in the present, but pushing very fast into the future. What do you see as the most surprising changes that we're going to see in urban transportation, and how will what we call cars fit into that?
So I think in some ways, what may be not surprising is that a lot of it in the future will look a lot like what it is today. And I think that's the role of the personal car. You know, for better or for worse, you know, the personal car is not just a means of transportation. It is something that appeals to your sense of social prestige, your what you like physically, your physical attraction to an object, in this case a car, and it's an emotional product. And so I think that the car has played that role for a very long time, and so it's always been much more than an A to B, going from A to B type of product. So I think in the future we'll continue to have that, because I think there's still a desire for those kinds of things that the car can meet. Of course, what we're talking about, I think a lot of times in the industry, is this idea of automated, connected, electrified mobility. And I think that would, if done right, I think done right, is all kinds of regulatory, all kinds of systems issues, pricing, et cetera, that will induce demand. That will, and this is known as the Jevons paradox, right? As you make something more efficient, that makes it easier for somebody to use it, and therefore you do more of it. So what I think could happen, therefore, are things like increasing vehicle miles traveled, increasing passenger miles traveled, and therefore increasing energy usage.
And increasing organizational challenges for the kind of work that Tiffany works on.
That's right. So a lot of work for Tiffany and companies like hers to really tackle and how to organize all of the movement of goods, peoples, and things in a city.
Okay, let me ask you one basic question, just sort of because I can't help myself. But are we really going to have, I mean, there was several conversations earlier today. I think it was Steve Mollenkopf was just taken for granted we're going to have autonomous cars soon. I find it very, I'm skeptical about that because of the social factors, which I know you spend a lot of time thinking about. People aren't really going to be comfortable with autonomous cars in any near-term future, in my opinion. But maybe I'm just a narrow-minded person.
Yeah. And what
do you think?
It's a very real thing, and it's like largely psychology. And I think the psychological factor is quite simple in my view. All of us basically have a need for a sense of control, whatever it is, right? And obviously there are things like we can't control, like the weather, right? But so therefore there are things that we want to control. And then when you or I in a car, when we drive it, we are in control, right? And all of us are above average, right, as we drive that car. When you are in an automated car without a driver or the computer's driver, you are giving up control. So the psychology of that is a barrier. Now, one can say, oh, if it's convenient, oh, of course, then we may be willing to do that. Just as the same that we have given up our rights or our sense of privacy and data to the big internet companies. And that's a whole other topic, of course, right? So we gain something from that relationship to the internet companies, so we give up privacy, right? And so in the same way, that will happen with automated driving, but we're not comfortable yet right now because we yet haven't experienced it. And this is why I think in another industry, in aviation, why I think a lot of us are hesitant to get into an airplane driven by a computer only, right? We like the fact that there's a human in that cockpit who has...
Even though a computer's really driving
right,
it. Yeah.
Because I give up control of flying the airplane because I can't fly an airplane, but somebody is in there that's doing it that I have some comfort around. So the control and comfort issue is very real. It's largely psychological, but it's significant in that regard.
So are you assenting to my question that you're skeptical too about how soon we're going to have autonomous cars?
I'm only skeptical because if we as the engineers dismiss the psychology of it, then that's not good.
Right. Which
because
has basically been the Elon Musk approach, right?
Because somebody will read the paper about the psychology of it, and we'll get it, and we'll have a product that people love. Okay, and we know this thing happens. But I believe that despite the skepticism and also that the real technical challenges that have to be solved, I think they will be solved. The big question is when.
So you sort of see it as a product design challenge in a way, almost.
I do. I really do.
And I know you also believe that the future of all this autonomy stuff is going to involve a lot of machine learning, right?
Absolutely.
And just quickly talk about that, and then I want to sort of dovetail that with some of the work Tiffany's doing.
Yeah, and as Steve Pawlowski from the previous panel said, that the more data, the better. The reason why machine learning is the basis of virtually all of the automated vehicle demonstrations that are going on and are in development are based upon machine learning technology and all the associated things around it. So that is essential, and that's why we have partnerships that you see happening right now, because then the more players in a given alliance or partnership, the more data you can amass faster.
So but going to the issue of this hardware versus software versus internet kind of element that I was talking about in the previous session, do you think that these new data management techniques that we've been hearing about today, and how, if you can have big, like just in the last panel we were talking about large memory right there with the processing, is going to allow far more insight faster. Would that apply in transportation too?
Yeah, I believe so, because connectivity is the thing that's happening as well, but it's not guaranteed. And to have a mission-critical system, in this case, driving based upon connectivity, would be a failure point that could result in something really bad happening. So having the processing on board the vehicle is, in my view, essential, because you don't want to depend upon connectivity because you don't always have it.
So Tiffany, you're interfacing with urban designers and system planners all over the world. Are they already thinking about things like flying cars integrating into the system, or are they just trying to reduce the traffic jams that are plaguing them today?
So to give a little context, we at Remix, we work with about 325 cities across 17 countries in the world. And what we've seen is that AVs kind of like overtake press and PR. Whenever you open the New York Times, there's like another article about AVs.
Autonomous vehicles.
Yes, yeah. Autonomous vehicles. But then when you're actually in a public meeting or at a city council meeting or in a planning department, people are just talking about what's happening on a day-to-day basis, which is traffic. And if you think about traffic, I mean, everyone complains about traffic, but in reality, you're not in traffic, you are traffic. And that is never going to change whether or not you're the driver or whether or not you're a passenger in an automated vehicle. And if you think about a really simple concept around space or geometry, what have you, it's all about getting the most amount of people from point A to point B, And if we're the same amount of people, not even counting for population growth in cities, we're the same amount of people utilizing the same single occupancy vehicles from our home to our jobs every single day, not even counting for induced demand. If we were to widen the 101, that would just induce more people to drive and more traffic. What you have is just untenable congestion that will continue to be that way throughout the course of history. And yes, maybe we need to elevate to the three-dimensional and get people into the air through various copters, which would completely transform mobility in a way that we've never really seen before on a consumer level, which is really exciting. That could be one solution, but are you going to bring everyone to the air level? Then you just have air congestion. And so it comes to be a problem around prioritization of mass transit above the single occupancy vehicle. And that is how you solve for space in geometry, which will never change.
So that's a policy issue, really, more even than a technology issue or even a planning issue. It's a decision that cities have to make of what do they really want. Do they want more congestion of the kinds of things we have now? Scooters is another example where there's bizarre congestion issues, particularly in Paris, where they have 20,000 scooters currently with 12 different companies operating right now. So what do you think about that?
Yeah, it's a policy question. The policy question is not necessarily like, so the policy question is more about who as a city do we value and how do we want to prioritize the very limited allocation of space on our right-of-way, on our city streets. If you look at a city street today and see how many lanes are dedicated towards cars, like sheer proportionally, like, 4 lanes on Howard Street, all cars, and then, a bike lane that's about 5 feet wide, and then there's sidewalk that's about 7 feet wide, you start to get a sense of literally we're allocating space based on how we prioritize and who we think is more important. Is it the driver, or is it the cyclist who's using a sustainable mode of transportation, using much less space by transporting themselves? Or do we need to actually incentivize both private companies and societies and communities to embrace more sustainable modes of transportation? For example, scooters. I think one really big flashpoint for cities is scooters because there's so much demand for people needing to get from point A to point B, but there's like no place to put them. Do they go on the sidewalk and then they crash into pedestrians and senior citizens? Or do they go in the street where scooters are very likely going to get run over by a crazy speeding driver because the driver is just so much larger and has so much more metal behind them in terms of safety than a scooter? And so it starts to become a question about policy and allocation of space based on the priorities of who we actually want to make space for in our communities.
But now you've been in the transportation industry for a long time. Wait, what's that company you were I'm blanking on the name of that famous company.
Oh, Zipcar.
Zipcar, you were the first...
I was the first user experience designer.
User experience designer for Zipcar. So you've been thinking about this kind of stuff for a long time, because that was a while ago. So as you look at everything you've learned in your career and being a designer, and now with this kind of exploding company that you didn't even intend to be a company, what do you think is the role of data and computing as we're going forward? I mean, this is a technology conference. I want to hear your observations on, how much processing and optimizing with software we're going to need to do and how we're going to do it. I mean, because I do think in the 5G era, the amount of data is going to be just spectacular, and it's going to allow for a lot of new stuff. Or is that part of your thinking?
Yeah, and I'm going to actually take a little bit of a contrarian view.
Okay.
On stage here, being in Silicon Valley. I think technology is obviously changing everything. I mean, I'm a technology startup co-founder, but I honestly think that when it comes to data, you can't start with the data as like the single source of origin. You have to start with the problem that you want to solve. And if the problem is congestion, or if the problem is access, or if the problem is mobility, you have to figure out what are the right forms of data and the types of data that you need to do either machine learning on or AI or ML, whatever, and then be able to apply that to the problem. Because if you just start with the data, then you're just technology looking for a solution and not actually solving a problem.
John, what do you think of that?
In a similar way, I maybe contrarian. I think that my analogy is you've heard data is the new oil. I think my analogy is data is the new dirt. Dirt as in the dirt that you would need to dig out to get gold. Like there's this show on History Channel, whatever, that there's like gold miners, and they're digging a gigantic, they're just demolishing a mountain to get a little bit of gold, right? And I think data is like that. It's like there's stuff, but it's not all valuable, right? And so what's needed is, but you want the dirt to get to a little bit of gold. So I think what's needed is, I do anticipate, through sensors, connectivity, computing, et cetera, we're going to have a lot of data, but you're going to have the people to, I think that's the important constraining resource, is the people that understand how to mine the dirt to get to that bit of gold that's really, really valuable, and then do something.
So again, it's a programming challenge and coming up with the right kind of algorithms based on really the values that you've defined. Yeah. So Rene, I mean, you talk about 3D in the air. I will say, your business is one that will not have any hope of succeeding without vast amounts of data processing, because customers simply will not be comfortable being up there unless they're confident that it's safe, and that's the only way probably that it can be made safe. Would that be a fair statement?
Yeah, absolutely. And I would 100% concur with what John said. I think part of the challenge will be to move the processing before the data storage. And as said, as it will be for Micron in a way, they won't store all the data that is being generated, because you need to filter out what is the really valuable and valid data that you're generating. So, practical example, I have a 1 mile or 2 mile or 3 mile forward-looking radar which scans the entire airspace in front of me, but the only thing I really care about is a couple of birds and maybe a drone which is coming up and which I want to monitor. So part of the data management needs to be a device which filters that data before it goes into storage and further processing. And that is, I think, also required for the data being generated on the ground. And then, of course, these filters will apply to different means of analysis. So probably Tiffany will need data at a later stage, where she even needs more filters in front of it to bring it down to the really valuable and valid data that she needs in her system. Then I need in the instant control of the airspace around me, and which I'm happy to lose right after I have controlled that airspace.
So John, when Hyundai is thinking about the next generation of cars, four-wheeled street stuff, are you thinking of how it will dovetail with and intersect with all the other modes of transportation, mass transit, scooters, pedestrians, et cetera, ultimately volocopters?
I think we do, but we try to understand the future use case, which oftentimes is in cities, and very congested cities. And so we're trying to understand how does that vehicle, a four-wheeled vehicle, fit into the bigger picture of that individual, using that vehicle for some time, but they might also walk, they might use a bike, scooter, vertical takeoff and landing aircraft, et cetera. So we definitely think about that. We also spend a lot of time thinking about the value of that person being in that space, in that time in that vehicle, and how can we improve that experience to make it delightful and great and wonderful too.
I think all three of you agree that we are probably headed toward a more efficient, but still congested. I think more or less both of you have said, regardless of what we do, we're going to be wrestling with congestion one way or another, right? Because, as you said, more resources generates more use, right? But we'll have probably better cities in one way or another. Are you confident that cities are getting better or not?
I'm actually a little bit worried a lot of the time when I see how much faster technology is moving compared to cities' abilities to be able to understand the framework for how mobility should happen. Because, cities, when scooters landed, cities were like, oh my God, I don't know what to do with this. I've never seen this before. Let's halt them. Let's ban them. Let's take them out of my eyesight. And I think that's not the right way to approach innovation in a lot of ways. You want to experiment. You want to test things out, of course, safely, but you want to allow the private sector to innovate faster. And then the public sector should harness that innovation and bring it to the citizens in a way that is safe, is equitable, and is sustainable, because no one else has those values other than the city itself.
Yeah, public sector innovation sometimes we shouldn't be holding our breath. But that's a good thought to end on. Thank you so much. Thanks to all of you.
David.
Thanks.